Corporate Finance Excel Practice Problem. Present value of an annuity. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and are following along, note we are in the Practice tab. The first tab will have the answer to it. That'll be the answer key. Information is going to be up in the upper left. We're going to work this a few different ways. One, with a mathematical formula. Two, we'll do a running balance as we go through this. Then we will do the formula within Excel, and then we'll take a look at the table so we can calculate this many different ways. We're going to start off with the equation, the mathematical equation. Information up top, it's a present value of an annuity. We're going to receive per year $11,000 for 18 years at the 14%. Therefore, and then we are going to be looking for the present value calculation. In other words, if we're going to be receiving $11,000 per period, in this case, periods being the 18 periods, 18 years in the format of years at the 14%, what would be the present value of that stream of payment at this point in time? Or in other words, the current value equivalent of that stream of payments, pulling it all back to the present day dollars. Okay, so we're going to then start off with P. We need this formula down here. Note it basically has P times this whole thing in the inner box. That's what I want in the outer column as we do this in our kind of table type of format. Then the numerator is going to be the most complex part of the calculation. We're going to break that out, the numerator and denominator in this column, and then we'll break out the numerator into a bit more detail in the inner column. Let's see what that will look like as we build this thing. I'm going to first set that P is going to be in the outer column. So I'm going to take the outer column here, which is going to be the 11,000. That's going to be the payment that we're going to be receiving. Now I'm going to go to the inside 1 minus 1 plus R to the negative N. I'm going to start with just 1 and then do the inner part up here. So I'm going to say 1 in column F, and then I'm going to go to the rest of this business up top, which is 1 plus R to the negative N, which I'll do down here. We're going to start off with 1 plus R, that's correct, to the negative N. R is going to be the 14%, so I'm going to say this equals the 14%. We will then percentify that by going to the Home tab, Numbers, Percentified, underline it, Home tab, Font Group, underline it. Sum this thing up. If we say equals SUM for the trusty sum function, there is that. Let's percentify that. Home tab, Numbers Group, Percentify. There we have that. We're going to take it to the power of negative N, which is the number of periods, in this case, years. So I'm going to say negative of that 18, and then I'll underline it. Home tab, Font Group, underline that. And then I'm going to bring this out into the outer column so that we can take this part, 1 plus R to the negative N, and then subtract it from 1 here. So I'm going to say this is going to be equal to this number to the power of shift 6 caret I'm sorry, that's the other way around. Hold on a second. This is the 114% to the power of shift caret the 18. So then we have the 18, and then let's add some decimals here. Home tab, Numbers Group, adding some decimals. So there we have it. So we can have a bit more detail in our calculation. I'm going to then do this calculation. So we're going to bring this out to the outer column in F here. And so it's going to be then the 114% to the 18. So this is going to be equal the 114% caret shift 6 to the 18 periods. Adding some decimals. Home tab, Numbers, adding some decimals here. Bringing that out for a bit more detail. Then now we've the 1 minus the 1 plus R to the negative N. So I'll subtract that out here. I'll keep that in the same column. We could make another column here, but I'm gonna subtract this out in the same column. This is gonna be the 1 minus that amount. So that's gonna be our numerator. Let's go back on it, add some decimals. Home tab, Number Group, adding a few decimals there. So there we have it. So now we've got basically our numerator calculated. The denominator is just R. So let's just pull that. This is gonna be equal to the rate, which is R. And then Home tab, Numbers, percentify that. Home tab, Font, underline that. And then we're going to bring this out to the outside numerator and the denominator, which is going to be equal to this and the numerator divided by the denominator. Let's add some decimals there. Home tab, Number, adding some decimals to that one. Underline it as well. Home tab, Font Group, underline. and then we'll get to our ending number, which is the present value, which is going to be equal to, we now have P, which is the 11, times this whole thing that we calculated here. So now we just did P times this whole thing. That gives us the 71,141. Let's add some decimals, home tab, number, couple decimals there as well. So there we have it, annuity 11,018. We get to the 71,141.63. Let's do a running balance type of calculation, something you probably don't see as often in book type problems. In practice, very common, very useful, and with Excel, very easy. So I'm going to say starting off with 1, 2, and then I'm going to do the good old autofill, selecting 1 and 2, and then autofill handle it down because Excel can figure out that progression. And we're going to go to the home tab and then alignment and center it. And we're going to be starting off with period 1 here is going to be, I'm going to say the payment is 11,000. So now what we're going to do is we're going to break each of the payments down to their current value using a normal present value calculation, not a present value of an annuity. In essence, what we're doing is taking the present value of an annuity, and because they're fixed values, we're able to simplify and use one formula instead of present value in each category or each year, each period. But here we are going to go back and basically break it down into the present value of an annuity into each individual single amount, which would be tedious to do if you didn't have Excel. But with Excel, it can add some more value to it and let you see kind of the relationship between a present value calculation and present value of an annuity. So what I'm going to do is for each period here, we're going to bring the payment back to the present value. So this is one period out. We're going to do our present value formula. This equals the present value in Excel. We're not going to be using this for an annuity, but present value of 1. We're going to take the rate here at the 14%, comma. We're going to take the number of periods. Will be 18 for the entire annuity, but for this one payment, it's just one period out. We're just talking one period out, comma. We're not going to have payments here because we're not talking about an annuity, so I'm just going to enter another comma. We are talking about an annuity over here, note, but we're breaking that annuity down into singular payments. And then this is going to be the 11,000 and enter. I'm going to make it a positive number by double clicking on it, putting a negative before the P, and there we have it. So now this is going to be equal to the 9649 for our first item. So then we're going to have another payment, which will also be the 11,000. Now we're 2 periods out, in this case 2 years out, years being the period. Another present value calculation. This is going to be the present value of, and we'll pick up the percentage, which will be the 14% and comma. Number of periods, now it's 2 periods out. We're 2 periods out at this point in time. We're pulling it back 2 periods back. Then we're going to say comma, the number, there's no payment, so we could put a 0 or just 2 commas, and then the future value is that 11,000 and enter. Once again, I'll double click on it and put a negative in front of the P. It does what we would expect. The 11,000 that is 2 years out, if I bring it back 2 periods, 2 years, it's worth less than the 11,000 that would be 1 year out. So now we have the prior one plus this one for year 2. Let's do it again. Year 3 will also be, of course, 11,000. Present value calculation to pull the 3 periods back will be the present value of the rate, the 14%, comma, number of periods now 3, comma, and then we're not going to have a payment, so comma, and future value 11,000 and enter. We're going to double click on the item before it, put a negative before the P to flip the sign. There we have it. The 18,113 plus the 74525. Let's do it one more time. We've got the 11,000 here, 4 periods out. Present value calculation of 1. Present value calculation is going to be then the rate at this 14%, comma, number the payment is going to be 4, number of periods, comma, comma, payment, 11,000 and enter. Going to double click on it, put a negative before the P. So there we have it. So you can see that obviously the same 11,000, if it's 1 period out versus 2 versus 3 versus 4, will be a present value that is less. So now I'm going to add this up once again, and we'll use our this plus this, our autofill. Let's just autofill it one time down and see if it does what we want it to do. If it does not, we'll go in and see if we can fix any problems. So I'm going to autofill down. This 11,000 looks correct. That looks good. This one doesn't look right. What happened here? So it's got, this is our kind of complicated formula, but you can see right here, it's not taking into consideration the 14%. It moved that cell down. That cell, B4, needs to be an absolute reference. So I'm going to say, all right, let's do that. And then I'll go back in and fix it. I'm going to delete these three. Double click on this one again. That cell B4 right there. B4. What's B4? That's the cell, the B is for, anyway, I'm going to then put F4, hit F4. There's a $sign before the B, $sign before the 4. That makes it an absolute reference. We only really need a mixed reference, but why not absolutize it? It's been absolutized. Then we're going to say these three again and drag that down again and see what happens. Does it do what we expect? It looked kind of right. That looks good. This one double clicking on it, that looks good. And this one double clicking on it, I think it does indeed do the thing that we wanted it to. So then I'm going to autofill it down. We're going to select those items and then trusty autofill down. And there we have it. So we're coming out to that 71,142. Let's add some decimals to this column. Go into the home tab number and decimalize it. Decimalize it. There we have it. That looks good. And then we'll do, now let's do the formula that would be an easier formula, just an annuity formula, the magic one, the more magic. This is more magic than the last ones. So this is going to be the present value equals present value formula. And we're going to pick up the rate again, 14%, comma, number of periods is going to be, let's pick it up down here, 18 periods, comma, this time it's an annuity. So I'm not going to put a 0 here because it is an annuity. It's going to be that 11,000 for the annuity and no future value because we're doing an annuity this time. And there it is, one-time calculation, double-clicking on that, putting a negative before the P. So notice you can do this really quickly this way, but it's nice to see the running balance table too. And this is also really helpful if you can understand this and the use of the present value formulas here. Present value of one, present value of an annuity, so that when you have more complex situations, then you can see when to apply an annuity formula, when to apply a present value formula. Note that you could basically always apply a present value formula, but it's more tedious to do so. However, if you have Excel, not so tedious as it would be if doing it by hand. So then we're going to go back on over here and let's do it with a table, because that'll be fun. So we'll start with the 11,000, and then we need the table, look it up on the table, which is 18 years, 14%, 18 years. 14% is way out here, and 18 years is down below. There it is. 6.4674, 6.4674, 6.46, I forgot, dang it. Let's try it one more time. Now I don't even remember. 14%, 18 years. 14%. 6.4674. 6.4674. 6.4674. Adding decimals, home tab, number, decimalizing it. Put in an underline, home tab, font group, underlining it. And then multiplying 11,000 times that tabled amount. Let's add some decimals, home tab numbers, add a couple decimals, 71,141.40, a little bit different than this one here because of rounding on the tables. What would that rounding be? Let's go ahead and calculate what we think the table amount should be if it wasn't rounded or rounded to more than 4 decimal places. We would just divide these two things out. And there it is, 6.46742046.5 would be more accurate. And that's why this is slightly different than that.